All right. Hey, everybody. Welcome to DevSecOps with GitHub Actions. Uh, First of all, super excited to have all of you right here. We are going to give it probably a minute or two and get started very soon. I'm just checking to see if we are actually live, waiting for a little bit of confirmation, and we can get started. All right. Welcome everyone to DevSecOps with GitHub Actions. My name is Nithin Jois, and I'm one of the lead trainers at AppSecEngineer. I'm super excited to have you all here. So we're essentially doing a bunch of these live streams throughout this month as just to raise some bit of awareness since it is the cybersecurity month after all. And again, we have a couple of really interesting live streams scheduled in the coming weeks. I think next week we have one on threat modeling by Abhay, which is going to be really good. So I would highly recommend that you show up for that one as well. But in today's current live stream, my plan is to go ahead and talk a little bit more about DevSecOps. Uh, Traditionally, DevSecOps, the way I see it and the way I've helped quite a few organizations implement it, they have their entire CI/CD tool. They integrate a bunch of security tools as part of their entire build pipeline, and they try and run these security checks quite regularly and want to start collecting all of these results. But today, I want to essentially talk about some of the different approaches you can take while implementing continuous security for your entire application development, right? So if you want to go ahead and have a pretty secure SDLC, we're going to be looking at multiple options that you can leverage and use as potential alternatives to something like Jenkins, essentially, right? So, and I'm going to be concentrating mostly around GitHub Actions, GitLab, and I'm also going to be talking about a really interesting approach, which we definitely recommend at AppSecEngineer and at V45, which is using ephemeral environments to run your security jobs, right? So we're going to be looking at how you can start leveraging things like AWS serverless or AWS Lambda or something like step functions to go ahead and start running your security scans and your all of your tests in ephemeral environments. So you're not going to be charged all that much when you are actually going to be running some of these scans. All right. So again, I have a couple of slides prepared for today. Nothing too much, not too theoretical. I am going to be showcasing three demos at towards the end. So with that, I'm going to go ahead and share my screen, and we can get started. All right. So I am hoping my screen is visible right now. Now, whenever you think about implementing continuous security or whenever you think about essentially being more efficient, every organization has pretty much the same goal as long as they're profitable, right? So they want to be profitable, which is to try and increase the throughput and decrease some of the operating expenses. And the only way, or one of the only ways to go ahead and achieve this is through automation, right? So the more you can automate some of the processes and some of your security checks, you're going to have much better applications that are going to be developed, that are going to be delivered. So it's going to be a lot higher in terms of quality. And since security is going to be a continuous process, and since it is going to be running continuously, some of your security issues are not going to pop up all that much anymore as well, because you are constantly looking for it. At the same time, there is going to be a huge decrease in operating resources because, again, our goal is to try and automate as much of this as possible, right? So this is going to be done based by decreasing the overall resources consumed while testing, right? So all the resources, whether it's going to be man hours or whether it's even going to be like your server environments or something like Jenkins, which can sometimes be high, which can sometimes have high compute requirements. If you can manage to reduce the resources that are going to be consumed, it's going to go ahead and decrease your overall operating resources, and it's going to be a lot more efficient as well. Now, additionally, at the same time, if you can decrease the resources consumed while fixing these issues as well, that's an additional bonus, right? So some of the examples for this would be if the tool that you're using can additionally provide remediation techniques, right? So on how a developer can go ahead and remediate it, so that the developer themselves do not have to go ahead and further research into the security issues. So they can just look at the result provided by the tool and go ahead and get started with fixing it. So this is going to play a critical role in terms of the time consumed while decreasing some of the resources as well. And finally, resources that are consumed while firefighting. Now, I'm sure multiple teams across the world constantly face these issues where they just deploy something to prod, and as soon as that's done, even though everything might have been tested thoroughly, something goes wrong, like some functionality breaks or something ends up having unintended consequences. And more often than not, if they are not continuously looking for security checks or even performing functional automation in an automated fashion, uh, it can lead to a lot of firefighting, and a lot of bugs tend to pop up as soon as something is released in production or even in a dev environment sometimes. Now, when you look at some of the contributors to velocity itself, right? So whenever you want to go ahead and essentially increase the efficiency or the overall go-to market strategy when it comes to deploying your application, what we often typically see is a lot of folks or a lot of organizations are moving away from monoliths to microservices. And this is something that we've obviously been seeing a lot in our industry as well, right? So we're constantly seeing people moving away from a monolith application towards something like a containerized application, or even to something like Kubernetes clusters, or even serverless for that matter. And at the same time, there's also going to be things like high velocity engineering tools, frameworks, and concept compression. Infrastructure and cloud native environments are definitely playing a huge role, right? So previously, if you had to go ahead and deploy something, you had to spin up a server, install all of the necessary requirements, clone your application, code inside it, potentially build it sometimes. And finally, once all of this was done, you then go ahead and deploy your entire application on your server. But now with things like Terraform or even Kubernetes manifest file, all you have to do is spec out your requirements in a file and just have the service provider consume it and deploy all of your resources for you. So I can specify my server requirements, what dependencies I need to be installed, the build commands, as well as the deployment commands. All of that, I can simply write it in a script, and I can go ahead and start continuously deploying the script as well. And obviously, it leads to rapid deployments. And finally, we also have continuous integration and continuous delivery of our application as well, right? So you're going to have your functional automation scripts, your unit test scripts. Additionally, at the same time, it is highly recommended that you go ahead and have a few security checks as part of your CI/CD pipelines as well. And that is something that I am going to be talking about very soon. Now, the modern stack is something that I am going to be referencing a lot. Now, whenever I talk about a modern stack, I typically mean a more distributed environment, right? So anything that relies on microservice-like architecture, whether it's going to be containers, which are split up into multiple microservices, or something like Kubernetes, which essentially orchestrates all of these containers, which are going to be running on a Kubernetes cluster. Now, additionally, even serverless, something like serverless or AWS Fargate, all of that come under the entire microservice style architecture as well, right? So you're taking a typical monolith, which is this application which has a bunch of functionalities. And you're going to start breaking this application up into individual services. And you're going to be deploying these individual services as microservices. Again, whether they're as Docker containers, or whether you're going to be deploying them as pods on a Kubernetes cluster, or whether you're going to be deploying them as functions on something like AWS Lambda. Now, obviously, one of the key advantages of doing this is scalability, and it's also highly flexible, right? So just as a quick example, let's say I'm developing a microservice, right? So I obviously have multiple functionalities. Now, if I know for a fact that one of the functionalities perform better in something like Golang, I can go ahead and write that certain set of functionalities in Golang and go ahead and deploy it. At the same time, these are extremely scalable as well, right? So if you want to go ahead and scale this and create replicas for your containers or even for your Kubernetes cluster, it is extremely simple to do so. And serverless, on the other hand, is a whole other story, right? So serverless typically is horizontally scalable. So if the number of requests that are coming in to your application increases, it's just going to go ahead and spin up multiple serverless functions or these ephemeral environments, which are going to respond back, and it's going to finally destroy themselves. And additionally, because of all of this, we tend to embrace the entire multi-platform or language implementations. Like I just previously mentioned, if I want to go ahead and have my entire application deployed in a combination of, like, let's say Node.js, Golang, Python, and a couple of other languages, I now have the freedom to do so, which I previously did not have with something like a monolith application, right? So I can go ahead and identify what functions perform best in certain set of languages. I can go ahead and develop those services or those functionalities in those specific languages. Now, when we speak about continuous integration and continuous delivery, we have this entire process, right? So we go ahead and plan what our application needs, the functionality itself, and then we hand it over to our developers who are going to write code for the entire functionality or the application itself. Now, once this is done, the planning phase and the coding phase are obviously going to be manual. But once this is done, the building phase or the entire testing phase even can be automated, right? So what we see on the screen right now, from the build to the unit test and to spinning up the test environment and even running some of these integration tests, all of this can happen in an automated fashion. And it typically happens in a separate staging environment, right? So the last thing you want to do is go ahead and run a bunch of integration tests in production. So only once all of these tests have passed, right? So whether it's integration tests or user acceptance tests or even load tests or performance tests, once you get a green light from all of these automated tests, only then you would go ahead and deploy it to the production environment, where the deployment itself is going to be continuous. At the same time, you will also want to monitor your production environment as well. But one of the key things that is missing in this entire approach is security, right? So the need of the hour right now is to find and fix some of these security bugs that can potentially pop up as early as possible, at the same time as often as possible. right? So the best approach would obviously be to go ahead and train the developers in terms of security, and first have them start developing uh, applications which are relatively more secure. But again, there can be a few security issues that can potentially pop up, right? So at the same time, what you'll also want to do is start integrating security with your agile development. Now, on a quick side note, uh, if any of you folks are interested in having your developers trained, or if you yourself are interested in getting trained in terms of security and DevSecOps and container security and Kubernetes security and all the good stuff, I would highly recommend that you head over to AppSecEngineer.com. We are running a huge discount right now, and I think it would be super beneficial for you and your teams. Anyways, so continuing where we left off, we also want to ensure that security has got to be a little seamless, as long as it's going to be part of your continuous delivery pipeline. Because again, if you go ahead and integrate a security test, and that's going to be constantly failing the builds, or if it's going to create a lot more friction as part of your entire CI/CD approach, a lot of other teams are not going to be too happy with it, right? So our idea is to go ahead and ensure that all of our security automated tests are as frictionless as possible, and they obviously have to be well automated as well. So some of the likely trends that we are seeing is the developers are already consuming ops, right? So especially with things like Kubernetes and serverless, for the teams that are already actively using it, developers themselves have started writing your infrastructure as code specification and your Kubernetes manifest files, and they're also continuously deploying these certain set of functionalities or these functions or services onto the cloud environments. And it is very likely that the developers themselves are going to start consuming security as well. So, like I previously mentioned, right? So, integration is the name of the game, and do everything you can to try and decrease the overall friction that can potentially be there when you are going to be integrating some of these security checks. Additionally, try and move security from being a bottleneck to part of the entire engineering process as well, right? So, uh, more often than not, we speak to multiple teams where security is constantly blocking, for their own good reasons, obviously, but they're blocking the release of the application into production, right? So I'm sure all of these security teams have their own good reasons, but sometimes they tend to get a bad rep of being the bottleneck, which can potentially cause delays in the application itself being deployed. So try and identify what some of the things that can potentially be automated, and what are the things that can be a little bit more frictionless in terms of integrating security. And doing all of this again, it can be pretty effective in terms of both uh, speed and the scale as well, right? So if you have a plethora of applications and you want to go ahead and have security for all of these applications, you would probably want to get on the DevSecOps bandwagon and start automating all of your test cases in order to being able to manage all of the security checks that need to be performed. So when it comes to security in DevOps itself, we can actually integrate security across the entire software development lifecycle, right? So in the planning phase, you can go ahead and get started with threat modeling the entire architecture, whether it's your solution architecture or whether it's your cloud architecture. You can go ahead and get started with the threat modeling process initially. Once that's done in the coding phase, or when your developers are building the application itself, you can go ahead and get started with uh, a static analysis, right? So whether it's a SAST or SEA tools, you can go ahead and start running these checks to ensure that the code that is being written is secure. At the same time, the third-party dependencies that are being used in the application are not vulnerable as well. So once the application is built and once it's deployed to the staging environment, then you can go ahead and look at dynamic application security tests. You can go ahead and run a bunch of DAST scans, or you can also integrate IAST. And finally, just before the release, you'll also want to check the infrastructure as code as well, right? So the security in that, because the problems that we tend to see as people are rapidly moving towards cloud environments is cloud misconfigurations. And all of this are fairly easy to catch if you're using the right approach and if you're using the right set of tools to go ahead and essentially integrate all of this as part of your lifecycle. So ideally, before you actually go ahead and deploy your infrastructure as code onto your service provider, try and ensure that you are running checks for potential security misconfigurations in your cloud architecture. And finally, once it is deployed, you can go ahead and start monitoring the application itself and also try and detect for some of the attacks. Now, whenever we talk about DevSecOps, some of the common problems that we often see is they try and think of DevSecOps as the fix all or the silver bullet, right? So they typically have unrealistic expectations where people think, hey, you know what, if I go ahead and implement DevSecOps successfully, if I go ahead and integrate these bunch of tools, my application is secure. Unfortunately, that is not how it works. Right, so you'll still need active pen tests that are going to be happening, your active, occasional VAPT. All of that is definitely going to still be necessary, but at the same time, uh, having DevSecOps in place is going to start ensuring that the common occurrences of security issues don't keep happening over and over again. And at the same time, there's going to be a lot more discipline in terms of building the application in a more secure fashion. And when it comes to continuous integration and continuous security, one of the common arguments that we get into is breaking the build. Right? So people think, hey, you know what, if there is a security issue, we've got to go ahead and break the build. Now, breaking the build is a subject onto itself, right? So it's going to be a pretty long discussion. But on a very high level, I would probably withhold the breaking the build to more mature teams who've already figured out how to implement DevSecOps successfully. Right. So if you're just getting started with DevSecOps, or if you're simply exploring the idea of essentially implementing DevSecOps in your organization, I would probably not break the build initially. Right. So because again, that's going to have an additional friction point, and other teams in the organization are not going to be too happy about the delay in the entire build itself. Right. So again, if you're simply getting started, or if you're still new to the entire implementation of DevSecOps, I'd probably hold off on the breaking the build part. So, like I just mentioned, right? So, DevSecOps is not a silver bullet. If you've had cultural problems before, especially friction between multiple teams or the developers and the security teams and all of that, that can lead to a lot of issues because all the teams will have to work seamlessly in order for them to be successful at security. Right. So, which is why go ahead and try and fix the cultural problems first if they exist. If they don't, then that's pretty awesome, right? So you don't have to worry about cultural problems. The next thing is security tests are not the same as functional tests. And people tend to get confused between the two, right? So functional tests typically have an expected condition. If I click on this button, it is going to direct me to this particular page right here. Security tests, on the other hand, you do not really have expected condition, right? So you can say, hey, you know what, I'm going to go ahead and fire this XSS payload, but for that particular payload, I can't really expect XSS to go ahead and show up. Like I can't expect a pop-up to go ahead and show up, right? So security tests are not the same as functional tests. So this is going to be a pretty big difference, as there are no expected conditions in all of the security tests. And if you're dealing with security itself separately and not your responsibility, teams tend to often fail at DevSecOps pretty bad because it is going to need constant communication and support from multiple teams in order for an organization to be successful at DevSecOps. So when it comes to unrealistic expectations, right? So again, whenever we're training at multiple events, most of the attendees themselves also initially tend to have unrealistic expectations, but they kind of understand where we are coming from once we get started explaining the entire process of implementing DevSecOps and how to go about it. So one of the key things is a lot of this automation depends on your tooling, right? So just dumping a bunch of tools as part of your CI/CD pipeline does not necessarily make you good at DevSecOps. Instead, it can actually cause a lot more pain, because if you have not gotten your tool right, or if the tool starts producing a lot of false positives, the team itself, they're going to be wasting a lot of time trying to fix the tool, and they're trying to go ahead and go ahead and look at all of the false positives that are being generated and all of that. And false positive is something that you will have to deal with, right? So there is no escaping from it. So again, focus on good triaging. Try and use different mechanisms to try and identify potential false positives. And at the same time, use the confidence score, which is provided by a few tools, and the severity score that is, again, provided by tools as well. And try and tune the entire false positive issues that can potentially pop up. If you are not able to do that, and if your tool is constantly going to be bombarding you with potential false positives, go ahead and look for an alternative tool. And again, security tests is not the same as your typical functional test, your regression test, or even your unit test, right? So try and understand that everything might not be part of the same build pipeline. You might also have to create a separate security pipeline itself, and not even bother with the build pipeline, especially if the deployments are going to be extremely rapid. Now, some of the engineering tools that work really well when you're working or integrating DevSecOps is, first of all, an issue management, right? So you are going to have constant issues that are going to be popping up. So using something like GitHub issues, or even Jira, or something like VSTS is going to be super helpful. The next one is Slack, right? So whenever you run a tool, let's say you want to be notified as soon as the result is generated. So you can leverage Slack or something like Discord, and leverage the existing webhooks to go ahead and notify you as soon as a scan is done. Also try and use pull requests and issues to a great extent, because again, all of these issues, the developers are going to be fixing it at end of the day. And more often than not, developers are going to be spending most of their time either on GitHub or GitLab or any of these other options. So wherever they're constantly going to be there, try and ensure that the security issues are visible so that they can go ahead and fix it. And also try and bring security into the entire sprint planning with threat modeling. Threat modeling is something that I would highly recommend every team should go ahead and ideally do it. And again, if you want to learn more about threat modeling, probably tune into the live stream next week, where Abhay is going to be talking in a lot of detail about how you can go ahead and threat model your applications. So additionally, what we typically like to do is we'll try and let the engineering team themselves manage and run the automation. Now, initially, obviously, as part of security teams, we help them integrate some of these security tools, and we also try and fine tune it. But once it's reached a certain stage, we essentially hand it over to them, and they can take over the entire process and ensure that it is run smoothly. And again, breaking the build, like I previously mentioned, this has a direct correlation to the function of quality of security tests that are being run. This is not the goal or aspiration, right? So the last thing you want to be doing in the organization is break the build, because it's going to lead to a lot of delays, and the efficiency obviously takes a hit because of that. But if the team itself is super mature and you folks know exactly what you're doing, breaking the build is a great approach that you can use to go ahead and stop deploying something insecure to production. But again, if you execute it badly, however, the teams are going to lose faith in security tests, right? So I have seen teams quarrel to try and get security tests removed from the build environment itself, because it kept failing and kept throwing a lot of false positives and all of that. So try and avoid that as much as possible. And if it's possible to not break the build, at least initially, that is something that I would highly recommend. Now, before we get started, again, a super brief on what SAST is, SE is, and DAST is. And finally, we're going to get started with the good stuff on cloud native and how to integrate it. So SAST, or static application security testing, on a very high level, it's going to be run against the source code that the developers have written. right? So it's going to be running against a non-running instance of your application. And one of the key advantages of this is your application does not even have to be deployed for these tests to run, right? So you can go ahead and run all of these security checks before you even go ahead and deploy your application. The next one is run source. This again runs against source code of binaries, and it's typically standalone tools, right? So you can just integrate it as part of your GitHub Actions or GitLab CI, and even if before it hits production, your security tests with SAST is already done. However, there are a few things in mind to keep when you're trying to implement SAST. The first one is if you can go ahead and integrate SAST in your developer's IDE itself, that is the absolute shift left approach one can take, right? So as and when the developer is writing code, she gets all the notifications necessary about all of these security issues, and this is probably the fastest feedback mechanism that's going to be available in terms of having a few security checks. The next one is to try and tune your SAST for high fidelity results, right? So again, sometimes based on your threat model, your application might not even be vulnerable to a certain group or a certain set of issues. So why even check for it if your application is not going to be vulnerable to it, right? So go ahead and try and tune to your SAST tools and ensure that that also tends to play a huge role in decreasing the false positives as well. The performance is obviously dependent on the size of code. If your code base is extremely large, it tends to take a while for some of these scans to run. However, one approach which we typically recommend is to go ahead and use the incremental SAST technique. Now, what this means is, let's say I go ahead and commit a new piece of code onto the source code repository. Let's assume GitHub. Now, what I can do is I can go ahead and perform an incremental scan. I can go ahead and only scan the files that I have changed in my commit and not scan anything else, right? So it's going to go ahead and only scan the files that I have changed, and that's going to lead to faster results. And obviously, you are going to have to deal with false positives, especially if the tool itself is not tuned. On a very quick note, source composition analysis as well. Again, SCA, on the other hand, it's used to find vulnerabilities. It can also be used to manage license compliance, right? So currently, most of these source composition analysis tools, they do not support hardware supply chain security or IoT, but at the same time, you can generate SBOM. CodeDX is a great project, which I would highly recommend that you look into if you want to learn more about SBOM. So you can go ahead and manage the license compliance. You can also find potentially vulnerable packages or libraries that you're using. And at the same time, you can also detect some of the outdated components. Now, package management software, obviously, it allows for the end-to-end management of all of your dependencies for your application. And your deployment tools, whether it's Docker or serverless, they have a huge impact on supply chain security. So again, ensure you have your SBOM in order, know what you're using and know what is integrated in your application, your software bill of materials, and go ahead and run security checks on top of it. Check for license compliance such that you're in compliance and you're also secure. Now, when it comes to some of these success factors of SCA itself, package manager is the king, right? So it all depends on how well all of your packages are being managed. And if the package manager itself supports nested packages, something like NPM, it leads to a better coverage, right? So let's assume I'm using a package, Python package called request. Now, if this Python package called request is using some other package, something like urllib3, and urllib3 on the other hand is using a crypto package which is vulnerable, that means that my Python request package is vulnerable as well. So ensure that you have nested packages, you know all the dependencies of the packages that you're using, and you scan for security issues there as well. But at the same time, if you are moving towards the entire microservice style architecture, and if your entire if you're following the entire polyglot development, right? So if you're using multiple languages, it's going to be a pain to go ahead and integrate this because you're going to have to find different tools for different languages and go ahead and integrate all of this. Now, again, SAST and SCA for microservices is going to be a difficult thing. Like I just mentioned, if you're going to be using multiple languages, you're going to have to find multiple tools that do a pretty good job. And this also tends to increase the entire complexity of SAST and SCA as well, which is why it is extremely important to identify the right tools for the job. And finally, when it comes to dynamic application security testing, that is once your application is actually deployed into a staging environment, you can go ahead and start running security scans against your application. Now, typically, there are a few tools which do not necessarily provide good APIs, but they perform pretty good scans. But when you have DevSecOps in mind, or when you want to go ahead and actually implement DevSecOps, look for really good mature APIs, right? So because you are going to be automating this tool, ensure that the API is mature and well developed, because the integration is going to be pretty important. If you can additionally handle the entire proxy mechanism and the certificate handling programmatically, that's a great additional bonus. And you should also have the ability to tune the rules and the scan policies as well, right? So if you're able to tune the rules and scan policies, again, going back to the entire tuning your SAST approach, right? So if certain set of vulnerabilities are not part of your threat model, a quick example I can give is, let's say you're using an application with a NoSQL database, like DynamoDB, for example, right? So let's assume your application is using DynamoDB. There is no point in checking your application against SQL injection, right? So if you can go ahead and remove that from your scan policy, it's going to lead to a lot more. The scan is going to be itself is going to be a lot more efficient. It's going to be a lot faster. And at the same time, the overall false positives is going to be reduced as well. And if the reports are in parsable formats, whether it's JSON or XML, it's going to be fairly easy for you to go ahead and parse these results and either push it to something like Slack or even Jira or any other tool that you use to track all of these issues. So with that, let's look at cloud native DevSecOps, right? So a lot of teams still continue to use Jenkins to manage their entire CI/CD. In fact, if Jenkins for security is something that you are interested in, we are going to be launching a course next week on integrating DAST with Jenkins on AppSecEngineer.com. We also have Jenkins for SAST and Jenkins for SCA as well. So be sure to check it out, especially if you're going to be using Jenkins. But if you want to try and move away from Jenkins, however, cloud native DevSecOps typically means you're going to be leveraging several hosting environments to go ahead and run all of these jobs. The main idea behind this is it's going to save you a lot of money, right? So first of all, there is no maintenance required. So if I have a Jenkins instance running and a lot of teams are constantly using it, I'll probably need a separate team which is going to be exclusively managing Jenkins and is going to be responsible for all the jobs and all of that. But if I'm going to be running all of this in environments which are ephemeral or environments which I do not personally control, then I don't have to go ahead and worry about the maintenance requirements. Additionally, a lot of these tools do provide extremely powerful tooling and extremely powerful APIs as well. And some of these cloud providers, whether it's AWS or Azure or GCP, they tend to make this a lot more easier. So when it comes to DevSecOps on the cloud itself, at least some of my go-to options are leveraging GitHub Actions, right? So as soon as a developer commits their code, I can go ahead and start running a few security checks. Similarly with GitLab as well, right? So if a user commits a code, if they create a pull request, I can go ahead and integrate a bunch of security scans as part of GitLab CI as well. Now, again, this is something that you can also do with Azure DevOps, AWS Code Pipeline, and you can also start integrating multiple other tools as well. But at the same time, what you can also do for long-running jobs and all of that is start leveraging asynchronous cloud-native technologies. So things like your serverless functions, right? So let's say you want to perform the incremental scan, right? So developers commits probably 3 files. He makes changes in 3 files and commits a code. and you want to go ahead and run a couple of security checks. So you can just spin up a Lambda function, consume those three files, run the security scan, and publish the report so that the security engineer, she can go ahead and then start fixing the issues immediately. Right. So that's something that you can do. Now, again, for longer running jobs, let's say you want to integrate a DAST tool, you can go ahead and leverage something like Fargate, right? So you can containerize your OWASP app, which is a really great tool, especially in terms of DevSecOps, because it is extremely automation friendly. So you can go ahead and package it in a container, or you can use the official Zap image, run it as a Fargate job or as part of your step function, and run a scan against your application itself. Now, some of the example of cloud native DevSecOps pipeline is a asynchronous state machine with chat notification, right? So I can have something like a step function, which is going to go ahead, run some of these scans. And as soon as these scans are run, a Lambda function is going to notify me on Slack that a scan is done and the results are generated and ready, right? So that is going to be completely asynchronous. Similarly, we have AWS Code Pipeline, we have Azure DevOps, we have GitLab Serverless Pipeline, can go ahead and integrate that. And we finally have GitHub Actions as well. Right, so with that, let's get started with a bunch of demos. So first, I'm going to go ahead and showcase DevSecOps with GitHub Actions and GitLab CI. So I'm just going to pull this onto a different screen right here. So here I have DevSecOps with GitHub Actions. So I'm just going to head over to Actions real quick and let's look at what is happening. This is an open source project, so you can feel free to check it out. So I ran this scan a couple of hours ago because I obviously did not want to waste time in terms of running the scan during the live stream itself. All right, so this seems to have worked, right? So the previous scan, I think something was wrong with it. Not a problem. So I'm not in luck today, so demo gods are not with me. So it looks like the scan files have expired. It's probably just expired because I ran this a couple of hours ago and it seemed to have worked. But let's quickly go ahead and look at the workflow that is happening. And I'm going to show you the exact same thing on GitLab as well. Right, so here I have a bunch of jobs. The first thing I'm doing right here is I'm building my Docker image. Right, so as soon as a developer commits code, as soon as she does that, I'm going to go ahead and start building my Docker image. Now, as soon as my Docker image is built, I'm going to go ahead and run a scan using Trivy. Right, so Trivy is an open source project by AppSec, and I'm going to be leveraging this tool. I'm just going to zoom in a little bit. I'm going to leverage this tool to go ahead and run a scan against my build Docker image. The next thing I'm going to do is I'm going to run source composition analysis. Right. So since this is a Python project, I'm going to be using an open source project called PyRadar, which is actually developed by my friend and colleague Tilak. So I'm going to go ahead and leverage this tool, and I'm going to go ahead and upload this report that's generated as a artifact as well. Right. So I have gone ahead and taken care of my source composition analysis. Now, similarly, I can go ahead and integrate DAST as well, right? So in our example, I'm currently integrating OWASP app to go ahead and run a scan. So this is going to go ahead and run a scan against my application itself that is currently deployed. So this is typically what happens. I'm still not sure why this action seemed to have failed, right? So there seems to be an empty comment. Let's quickly explore what is happening right here. So the image looks like it was built successfully, and the Trivy scan is built as well, right? So the Docker image was built successfully, and the Trivy scan was run as well, right? So as you can see right here, the Trivy scan is done. Similarly, when we look at SCA, I think there is a version mismatch, right? So I think version 3.7 with architecture x64 is not found. I'll probably go ahead and fix this very soon, and you can find it on the same repository. It should be a fairly simple fix, but I'll go ahead and figure this out. And I'm sure it's the same problem with DAST as well, right? So this is typically GitHub Actions and usually works. But let's go ahead and explore something very similar with GitLab as well. Right, so in GitLab, I'm going to head over to pipelines. So in pipelines, let's essentially look at what is happening right here. Right. So I'm going to head over to pipeline, which I have right here. And as part of this pipeline, I have, first of all, I'm running SAST. So as you can see, I have run both a SAST scan. Since my application is Python, I'm going to be using a tool called Bandit, and that has run successfully. And it's essentially gone ahead and given me a warning because it's found a few high severity issues. And so if I go ahead and look at the result generated, it's going to have a few high severity issues that are generated, which is why it's gone ahead and failed. Similarly, I've gone ahead and integrated semantic grep as well, right? So I'm going to be leveraging semgrep to add a bunch of rules to go ahead and identify potential issues. So I'm using the security audit plugin, I'm using the secrets plugin, the CI plugin, as well as the Python plugin to go ahead and run a scan using semgrep. And it was able to identify my AWS access ID, my secret key, and a bunch of, it tells me that my hashlib is vulnerable and so on. Now, similarly, I have gone ahead and integrated source composition analysis with a tool called PyRadar. So this tool is going to go ahead, look for all of the third-party dependencies, and it's going to go ahead and save the result file as an artifact as well. And finally, I'm also going to be looking for secrets. So if I'm going to be using, if by some mistake, right, so I've gone ahead and committed some sensitive information, like I have right here with my AWS access ID and secret key, I'm using a tool called Git leaks, which is then going to go ahead and identify any high entropy string, which is identified on my code base. So once all of this is done, once all of these static security checks are done, only then I'm going to go ahead and build my Docker image. I'm going to build my Docker image and I'm going to push it to the GitLab registry, which I have set up right here. And finally, I'm going to go ahead and run a scan against the Docker file that I've used. And additionally, I'm going to go ahead and scan the Docker image that was built as well. Right, so I'm going to be leveraging Trivia again. I'm going to go ahead and scan that particular Docker image. And finally, once all of that is done, I'm going to deploy my application. Right, so I'm going to deploy my application right here, and I'm going to run a dynamic scan. I'm going to go ahead and run a DAST scan leveraging the API. Right, so I have a file here called end-to-end zap, where this script is responsible for proxying all the traffic through zap, and then it's going to go ahead and run a scan against my target application. Right, so this is an example of a complete DevSecOps pipeline leveraging something like GitHub Actions or even GitLab CI. So the next one, which I want to talk about, and we tend to use it a lot, is Amazon Fargate. Right, so Amazon Fargate is essentially a compute engine that allows you to run containers without having to manage your servers. So typically what you do is you define how much CPU requirements you need, the memory requirements, and you define the launch type, and that's pretty much it. Right, so you just tell it what container or what Docker image you want it to run, and it's going to be responsible for running it and executing the task for you. So you can have task definition, or if you want a more persistent service that you want to run on ECS, you can go ahead and do that. So it is recommended that you use this for event-driven functions that involve tasks that are relatively short-lived. Now, why Fargate? This is super useful when it comes to spawning containers as workers for jobs or for even long-running job, right? So a great example for this would be something like integrating a DAST tool. DAST tools tend to take a pretty long time, and obviously you can't run it in a serverless function. So what you can do is spin up a ephemeral environment like Fargate and go ahead and run your DAST scan from the Fargate instance. And once it's done, the Fargate container, it's going to destroy itself and you're not going to be built further. So, and additionally, one additional huge advantage is you don't need to manage infrastructure resources anymore, right? So you just set it up, and once it's done, it's going to tear down itself, right? So it's managed completely end to end. And Additionally, these are run as containers again, right? So it's very easy to go ahead and replace it or update it. And there's no specific need to go ahead and perform a live patch if you have to. So again, you can either run this as a service, which is going to be persistent, or you can run this as a task, which is going to be on demand. Right. So an example which we have right here is as soon as a developer commits code to Git, what we can do, since it's an event, right? So a commit or push is going to be an event. So we can go ahead and trigger a SAST job, which is going to be running in a Fargate container. So as soon as the SAST job executes successfully, it's going to go ahead and notify the security team on something like Slack. The next one is once the SAST job is complete, it's going to go ahead and then run our source composition analysis. Now, once that SCA job is done, it's going to notify the security team again on Slack. And at the same time, it can also go ahead and start raising issues on Jira. Right. So one of the key advantages here is you can add your own logic into these containers and have it perform essentially whatever you want it to perform. Right. So that's very advantageous in terms of flexibility of your security jobs that you plan on running. And finally, once that is done, you can deploy it to a staging environment and then run a DAST scan on top of it. Again, notify the security team, raise issues if you have to. And if you want to push it to a triaging system, something like Orchestron, you can go ahead and do that as well. Additionally, you can also leverage AWS Lambda, right? So AWS Lambda is essentially serverless, what we talk about, right? So function as a service, which is going to be invoked due to some event that occurs. Now, this event can be user generated, a user trying to access a certain endpoint, or it can also be an indirect event, right? So a user, through the application, a user uploads a file to an S3 bucket, and you want to go ahead and parse that, right? So that's a serverless function which you can invoke, get the result which was previously uploaded, and go ahead and parse that particular file. So again, AWS Lambda can be extremely dynamic in terms of use case, and you can go ahead and integrate a bunch of security checks. And you can also identify potential false positives by having your own logic integrated into a Lambda function where you can go ahead and parse the results and then run it through your logic. And this can, again, be used to trigger very short running security jobs. So anything less than 15 minutes, you can go ahead and look at AWS Lambda. So when it comes to some of the common use cases, like I previously mentioned, right? So if you want to go ahead and parse your result file and you want to go ahead and store it in a database somewhere, you can go ahead and leverage Lambda for that. And if you want to identify potential false positives, Lambda is something that can try and do that for you as well. Additionally, Lambda also performs incremental scanning. So whenever a developer, as soon as she commits code to the Git repository, you want to go ahead and perform an incremental scan only on the changes that the developer has made. Right, so you can go ahead and leverage Lambda for that. Since it's going to be just 2 or 3 files that are changed, the scans are going to be a lot faster. They do not require as much time, and you can go ahead and integrate Lambda into it. Now, the last thing I want to talk about before our final demo is AWS step function. Now, one of the key advantages of AWS step function is that it allows you to create state machines in order to run serverless workflows. Whether you want to go ahead and integrate AWS Fargate or AWS Lambda, you can go ahead and do that with step function, right? So you can essentially stitch all of this together, have a complete end-to-end workflow, and you can run it as part of AWS step function. So these workflows are very useful in DevOps and for other automation as well, right? So if you want to take decisions about the vulnerability severity or the false positive suppression, you can go ahead and leverage this. Additionally, like I previously mentioned, you can also invoke Lambda functions or additional Fargate tasks to go ahead and manage your workflow accordingly. This is great for modeling decision-based invocation, right? So if you have a decision-based invocation, I want to run a scan. If it fails, I want you to go ahead and perform these set of functions or these set of tasks that I want the workflow to run. If it passes successfully,
these are the different set of tasks that I want the workflow to run. So if your decisions are going to be based on either fail scenario or pass scenario, you can go ahead and look at a step function. So here we have a security workflow with step function, which I am going to go ahead and showcase. So as soon as a developer pushes something to the Git repository, what you can do is you can go ahead and leverage Fargate to run a bandit scan, which is going to be a Python SAST scan, which is going to run. And as soon as the scan is complete, it's going to push the result to an S3 bucket, and it's going to trigger a service function to parse all of these results and store it in a database somewhere. Now, as soon as this is done, and as soon as this entire task has passed successfully, you can then go ahead and launch a Zap scan, right? So you can have an authenticated Zap scan, which is going to be running as a Fargate job again. Once the scan is complete, it's going to write the results to an S3 bucket, trigger the service function to parse all of the result, and then you can notify the security team on Slack or any other service that you happen to use. Right. So what I have right here on my AWS console is I've gone ahead and deployed my step function. So I have a Zap state machine right here. I'm quickly going to click on it, and I've already executed a task a couple of hours ago. Let's go ahead and look at what has happened. So here I have a complete end-to-end workflow of what I had designed. Right. So as soon as I start this particular workflow, again, it can be automated as well. The first thing I wanted to do is run a bandit Fargate task. So it's going to pull in the source code from my repository. It's going to run a SAST scan, and it's going to notify me if the scan has been successful. Now, once the scan is successful, it's then going to go ahead and launch a Zap scan as well. Right. So Zap scan, again, they tend to take a pretty long time, and all of this can be defined in your Terraform. So you can go ahead and deploy this entire thing by leveraging infrastructure as code again. So you don't have to actively go to the user interface and start creating all of this. You just write infrastructure as code, leveraging something like Terraform, and it's that simple, right? So if you want to go ahead and make changes to your infrastructure as code and redeploy it, and it's automatically taken care of. So once the Zap scan is complete, it's going to notify me on success again, and it's going to start pushing all of these results to my S3 bucket. Right. So as you can see, it's also going to tell me the time taken in milliseconds, and typically your Zap scan tend to take a pretty long time. Bandit scan or SAS scan, not so much. Right. So again, you can also integrate source composition analysis as well. But once all of these scans are complete, if you head over to your S3, I have a bucket right here, and I can see that a bandit result was written successfully, and a Zap result, which is 1.5 MB in size, was written successfully as well. Right. So again, using this, I can parse all of these results with my Lambda function, push it to my database somewhere, and additionally notify all of the users. So with that, we have come to the end of our live stream today. If any of you folks have any questions or comments or concerns, leave them in the comments below, either on YouTube or if you're on LinkedIn, just you can reach out to me directly. And that is pretty much it. Again, I simply want to let you folks know one more time, we are running a really large discount on AppSecEngineer.com. So if you want to get trained on security with really good hands-on labs, or if you want to get your entire team trained in terms of security, you can head over to AppSecEngineer.com for a really large discount, or you can reach out to anybody from our team, and I'm sure they can point you in the right direction. Right. So with that, thank you all for watching.